Hi, this is Miss Fitzmaurice. This video is an introduction to rotational statics. So before you watch this video, make sure you've already watched the video on torque. And I'm going to tell you what rotational statics are, and I'm going to do one very simple calculation, an example calculation. So the main idea behind rotational statics is that there's really no rotational acceleration. Okay, so something could be moving around in a circle. So it could be rotating at a constant rate. Or just no rotation at all. Okay, so the conditions for rotational statics are two basic conditions. Just like something is in equilibrium when your net force is equal to 0. So one of the conditions for rotational statics is that sigma fx equals 0 and sigma fy is equal to 0, but it's also important that the total torque on an object is also to 0. So these are the important conditions for rotational statics. And so here's an example, and this kind of goes back to the meter stick example that I had before. Okay, let's say that you had a 50-gram weight, and it's all the way at 95 centimeters. You have a Actually, I'm changing the scenario. So we have 50 grams at 95 centimeters, and then let's say that it's balanced if your pivot is at 85 centimeters. And my question is, what is the mass of the meter stick? And B, what is Fn? Okay, so what's the force right here from the pivot? Alright, so we're going to go ahead and talk about our conditions. We have a force body diagram. We have Fg from the weight, and this is supposed to be a little w. We have Fg from the meter stick, and we have Fn upwards. Okay. In terms of torque, I'm going to draw these forces right on the meter stick. Okay, so I have at 95 centimeters, 50 grams down. At the 50 centimeter mark, I'm going to have mg down from the meter stick. I'll call that mgm for mg of my meter stick. And then I have this force Fn from the pivot. Okay, so I'm going to write out all of my conditions. I have sigma fx equals ma or equals 0. Well, there are no side-to-side forces, so that's already satisfied. Sigma fy equals 0. So that tells us Fn minus the mass of the meter stick, g, minus mass of the weight times g is equal to 0. Okay, but that doesn't help me calculate Fn or the mass of the meter stick because I have two variables. And then finally I have sigma torque equals 0. Okay, and if I draw a line to the pivot point, so this is my R, okay, this is my R for the meter stick, it looks like only this force and this force actually are going to have a torque. Okay, if you use the right-hand rule, which I told you about before, this will be a positive torque and this will be a negative torque. Okay, so we have F from, I'm going to call it FG meter stick, R meter stick, and it's sine 90, so I know sine 90 is 1. But that's negative plus FG mass times R mass sine 90, or I'm calling this W for the weight, sorry, equals 0. Okay, then I can solve for the mass. I can put the masses that I know in, I can solve for each mass, and then I can solve for Fn. Unfortunately, it is coming towards the end of the school day, so I am done giving you this lesson, and we will continue it in class tomorrow.